chapter 6 here. Well, we've been in 6. We're in 6.6, huh?
Yeah.
So there we go. 6.6. So we have the square root of 8x minus 5 equals 1. Like that. All right, so we're in chapter 6. We're wanting to finish up how you handle square root equations. So how do we do it? How do we actually solve square root equations? Yeah, you got to get rid of that root. Yellow and blue stuff's there. I get you your other exam later. So how do we get rid of that root? We second power both sides. Yeah, to get rid of a root, you 2 power both sides like that. Is that good? Does that make sense? Because we want to get rid of that root from the equation. So 2 powers take off roots like that. Does that make sense? 8x minus 5. And what is 1 squared?
1.
Just 1, huh? And that gets rid of the roots. That makes sense? That's how we handle a root that's in an equation? Like that? Yeah, totally. And then once we do that, then it's just normal from there. Totally, yeah. So plus 5. So yeah, so we just do regular from here. We get 8x is 6. Last step is divide by the 8. So x is 3/4. I just divided by 2. Top and bottom, and there we go. Is that okay on that? So when we have a root, we second power both sides. Questions I can answer? It's all well? I'll move on. You guys. So square root of y plus 1 minus 4 equals 6. Okay, so let me give you the plan. The square root with an equal. So kind of like, we got a recipe every time. So when you have a square root with an equal sign, what do?
Square.
You get that root alone first, yeah. And then you do 2 power both sides, huh? That's right. So yeah, so go ahead, get the root alone first. First get that root alone, then 2 power both sides.
You don't include the -4, do you?
Right, he's not in the root. So you first got to add that 4 to the other side there, yeah.
Oh.
Exactly. Yeah, does that make sense? So our first step is to add that 4 to the other side like that. And then we've got the root of y plus 1 is 10. Yeah, and then go ahead and 2 power both sides, right? That's what gets rid of that root, is the 2 power. 2 power. Rooting cancels squaring. Y plus 1 is 100, like that. Is that good?
Y equals 99.
And so then just subtract 1. Yeah. So y is 99. Is that good? Hey, is 99 really the answer? Let's just stick it. It is, yeah. I was like, was there a trick? There actually is a trick. It's coming, but this one doesn't have a trick. I just want to show you it is true. If you put that 99 in the first thing up there, the square root of 99 plus 1 is 100, right? And what's the square root of 100? 10. This would be 10. Minus 4. Yeah, it works, doesn't it? See how 99 really works? So that's really the answer. Good? Easy enough? So far, so good? So cube root of x equals -10. Now, what do you think I'm going to do to get rid of that root?
Times by x to the second. Square root of x.
I'm going to third power it, aren't I? Yeah. So just like on the other ones, I was 2 powering them, right? Because like right back here, this had nothing in the hook, which really meant a 2. And so I 2 powered both sides. Same thing on the other one. There was really a 2 in the hook, so I 2-powered both sides. This one has a 3 in the hook, so what we're going to do is 3rd power both sides. So whatever's in the hook, you just do that power, and that gets rid of it, doesn't it? That cancels it out. So that cancels it out. We just get plain old x. And then what happens on the other side? Minus 10 times minus 10 times minus 10
It's negative 1,000.
is negative 1,000. 3 negatives makes a negative, huh? Negative 1,000. Is that good? All's well? No questions, no troubles? So cube root of 2x plus 5 plus 7 equals 6. Let me let you try that one. So go ahead and try that one. Remember, you got to get the root alone first. First get the root alone, and then do the power thing on both sides. All right, so first step is get that root alone. Subtract 7 from both sides. We good? And then we have cube root of 2x plus 5 is minus 1, like that. So you always get the root piece alone first, right? Is that good? You get that root piece alone, and then you do the power that will on both sides, because you got to do the same thing to both sides, and that cancels out the root. And so then we just have 2x plus 5. What is the other side? Negative 1 times negative 1 times negative 1, which is negative 1, huh? Good to there. And now we subtract 5 for both sides. And we get 2x is negative 6. Last step, divide by 2. X is minus 3. How are we doing? How we got minus 3? A lot of us? Good. More than half. That's good. Questions I can answer? All good? All right. Okay. So we have x minus 5 is the square root of x minus 3. Okay. So what's the game plan again with roots? So let me write out the plan again. When you have a square root with an equal, let's be real clear. Get the root piece alone, and then you do the second power, or whatever power, second power, both sides, right? Okay, now, is this root piece alone? Yes. Yes, meaning on his side of the wall, he's all there is. He doesn't have like a plus 4 with him or, something extra with the root. On his side of the wall, he's all there is. Great. He's already alone. I'm just going to dive right into the parenthesis 2 power, parenthesis 2 power. So let's do that. So I'll just do that right away. And notice what I'm doing. It's parenthesis 2 power, parenthesis, because you're squaring the whole left side, squaring the whole right side. Good so far?
We're going to see the sea monster.
Exactly. The rooting cancels the squaring. Hey, by the way, why does rooting cancel squaring? I've been saying it all along. Are you comfortable with that? Because it means 2 of them, huh? Doesn't it mean, you don't have to write this out. Don't write this out. But let me just make sure I show you the reason. I don't like giving you things without good reasons. It means 2 of them, right? When you put a 2 on something, it means 2 of them. And you remember, like, what's root 7, root 7? Plain 7, right? Because if you have 2 in, 1 out, what's root 11, root 11? Plain 11, because 2 in, 1 out. Well, that's the same thing here. When you put a 2, it means 2x minus 3 is in, which is really 1 minus x3 out, isn't it? That's why it gets rid of the root. Makes sense? Same rule we've been doing all along. 2 in, 1 out. Is that okay? That makes sense? I don't want you to think it's magic or something. It's just the same rule. When you put it 2, I'm not saying you have to actually write this. Let's just skip it and I'm just going to write, 1 plain x minus 3. Right? But you see why it comes out? Why that pulls off the root? Because the 2 means 2. And when you have 2 whatevers, like 2 7s in a root, that's 1 out, right? 2 in, 1 out. 2 for 1 deal at target. That's the fundamental root rule, right? So same rule we've been following all along. Other side, x minus 5, x minus 5. Hey, what if somebody's there? Here'd be a good question. What if somebody said, hey, Mr. Why did you write 2 of the x minus 5s over here, but here you just did 1 of them? You're not doing the same thing. Everybody see why that is? It's because over here the root canceled out the 2. So there's just 1 of them. But on this side there's no root, so you have to actually write 2 of them, right? We all good with that? See the difference there? Okay. And so yeah, so that means on the left side I'm going to need to foil out. I'm going to need to go boom and a boom and a boom and a boom, right? So I'm going to get x squared minus 5x minus 5x plus 25, and the other side's just x minus 3. Good to there? Is that making sense on that? And now there's the sea monster. Like Renee was saying, that's exactly right. We see x squared, right? And, you know, I always do that because it just pops up out of nowhere all the time. And there it is, which means what? When we see x squared, we get a 0, right? Whenever. So it's like we've changed into a whole different kind of problem now. Huh? Halfway through, it becomes a different kind of problem. It becomes an x squared. And what do you, let me move it down a little bit. What do we always do with x squareds? We always get a 0, yeah. So as soon as you see that x squared, you get a 0, and you factor, you know, like with the parentheses and stuff. So yeah, so let's just get a 0. So here, let me gather like terms for some. What's this? Minus 10x. Okay, yeah, so to get a 0, then I just get rid of that x and get rid of, so just do the opposite. So that's just gonzo, 0. Whatever you do to one side, you have no choice but to do the same thing to the other. Is that good to there? And we get x squared minus 11x plus 28. So minus 10 and minus 1 more is minus 11. Everybody see why that's minus 11 there? And then we try to factor, you know, with the parentheses and stuff. Let me put it over here. So what is it, 4 and 7? Both minus, because that adds to be, or not add, multiplies to be positive 28, right? Negative times negative is positive 28, adds to be negative 11 in the middle, so that's right. And then so, and you know from here it's just opposite, huh? Can I just skip that step? So the answers are plus 4 and plus 7. You know when you set each one to 0, and just opposite like that. Plus 4 and plus 7. Now, it turns out one of these answers is actually a bad answer, and we have to throw it away. One of them's good. I didn't mention, but you do have to check these. So now I'll actually mention it because now we have to actually deal with it. Yeah, you have to, when you're doing square root problems, you have to actually check your answers because you can get false answers. What am I talking about? Well, let's go up here and let's check them, and you'll see what I mean. So it does make these a little bit kind of long, kind of tedious. So I'm going to check the first answer, x is 4, and then I'll check the other one also. How do I check? You got to go back to the very first step, you know, before you did anything, and you got to plug in that number, that supposed answer, and see if it really is an answer. See if it really makes the left side equal to the right side. So if you put in that 4, you get 4 minus 5. Other side, you get 4 minus 3. What is 4 minus 5? Negative 1. And this is the square root of 1. What's the square root of 1? It's just 1. Negative 1 doesn't equal 1. That's not true. 4 is not a good answer. How about the 7? Is it good? It is good. Let's check the 7. We check x is 7. We've got x minus 5 equals the square root of x minus 3. So put in the 7. You get 7 minus 5 is the square root of 7 minus 3. What's that? 2 is the root of 4. Yeah, root of 4 is 2. 2 equals 2. So 7 is the only answer. 7 works. 7 brings balance to the equation. Makes the left side and the right side the same.
But does Math Excel want you to put in the pair? Because it says use a comma to separate answers needed or...
As needed. So it's just not needed here. Yeah, so just the 7. Yeah, so sometimes both are good. Yeah, let me be clear. Sometimes both answers are good. Sometimes both are bad, and it's no solution. Sometimes one's good, one's bad. Usually one's good, one's bad, but not always. So you do have to check these. This method can bring in false answers. It's kind of weird, huh? We don't usually have methods that can bring false answers in, but this method's the best we got.
But math is always right. It describes the universe.
Math is always right. Well, math tries to represent the universe. It isn't the universe, right? It tries to model the universe and sometimes steps outside of it. So it's not always right, really. I mean, that's funny said. Math conclusions are always true, but they don't always. Yeah, I'm getting confused. So
funny how
we'll stop
many
there.
people use that in certain theories, you know.
Okay, yeah. So let me show you why. What did we do that made us get like a false answer? Well, we're using a method that can bring in something false. It's the best method we got. We're going to use it. But it can bring in false answers. What am I talking about? What did we do? What is the new thing we did that we've never done before? Square both sides. Well, it's a race now, but 2 power both sides. We've never done that before. 2 powering both sides can bring in falsity, something that's not true. How so? Well, just think about plain old numbers. If you take something like negative, well, I'll make it smaller. Negative 3 equals positive 3. That's not true, of course. That's not true. But if you square both sides, which is what we're doing, right? 2 powering both sides. Now, we don't see it because we have x's and stuff everywhere. And we don't know what x is. But I'm just showing you with plain numbers. If you take something that's false, something that's not true, and you 2 power both sides,
You can make it look like it's true.
now it's become true. What do we call that when you take something false and you make it look true?
False news?
Exactly. That's called lying, right? Exactly. That's what lying is, right? Take something false, make it look true. So this method can lie to us. It can lie to us. It can give us false answers. It can give us false answers. So we have to always watch it. Like if you've got a friend, if you got a buddy that lies sometimes, you always got to watch your buddy. You never know when the lie's coming out, right? Like that, right? It always makes me remember. I played tennis. And there was somebody on our team, and I liked him. He's a nice guy and everything. But we all knew he was a cheater. And so, he cheated. In tennis, when you play tennis matches, the team goes out and you play another school, and everybody calls their own lines. So there's supposed to be an honesty there. Unless somebody starts cheating really bad, then you call the coach over to call the lines. Well, almost every match, we'd be out there playing, and we'd hear from a couple courts down, some yelling and screaming and some calling over the coaches, and we'd all go, Kevin's cheating again. He just knew it. He cheated. That's what he did. So anyway, so this is what the 2 power method is like. It brings in false answers sometimes. You might think, well, I'll just see it when it does that. Well, it's not that obvious because there's an X. So you can't tell what it is, so it does it more slyly. So anyway, long story short, you got to check your answers. In this section, you got to check your answers. Here we go. So 7 square root of x plus 1 equals x. Okay, so same kind of thing. So you're going to need to check. So let me write out the 3 steps in. So for square root with an equal sign, step 1 is root alone.
It's minus x.
Oh, yeah, I messed it up. Thanks. Here we go. Get square root alone, and then the 2 power thing. And then 3 is check. So there really is a step 3. You do have to check. So that'd be the good thing to put on your 3x5 card for the next exam, which is far away. You don't have to worry about that for a while. Till next month. Like that. So the third, you have to check these, though. They can bring in false answers even if you don't mess up on that. Abraham.
I had a question. For the x squared, you said get the 0, and what was the second step again?
Factor. For x squared, factor.
Okay.
Yeah. So that's a whole separate process. You're totally right, though. So if you run into x squared, let's write that out, too. Get a 0. It's the sea monster thing. Factor with the parentheses. All right, so there's our 2 different processes, right? We have a square root game plan and an x squared game plan. They both will pop up in this one. All right, actually, you know what? Let me help someone on this one, because this one has one slight wrinkle. What's the first thing we should do?
Subtract the 1 from the 1.
Get the root alone. Yeah, so I'm just going to jump the 1, subtract the 1, same thing, same effect. So then we get 7 Square root of x minus 1 is x minus 1. Good so far? Now, what should I do if I was really, truly going to follow this plan?
Divide the 7.
Divide the 7, because the 7's not, I mean, the root's not quite alone. Now, I'm not going to do that. Hold on. That's why I wanted to show you I'm going to do something different. But technically, if I was going to follow the recipe there, I would divide the 7, because that would get the root alone. That 7 is times, isn't it? It's right up against the root, which means no symbol in the middle means times. So I'd have to divide. I can't subtract it off. It's not added. That 7's not added. I'd have to divide. It's multiplied, so I'd have to divide it off. And that'd be a pain, because then I'd have a fraction over here. I don't want to go there. Can I just not? Yeah, you actually cannot. I'm giving you these instructions, but I don't mean them. I'm giving you these instructions, but you don't have to do... I'm giving you the general, usual, typical best way to go. But in this case, it's okay to leave that 7. I'm going to. It's okay to leave a number multiplied. How do you know that? Well, remember what causes all the problems in math? It's adding, subtracting. It's the Costco glue and all that painful stuff. A number multiplied is really not a problem. So when I say get the root alone, you know what I really mean? I mean, get rid of anything added or subtracted. That would be the real pain. Yeah, you got to get rid of that 1. He would cause all kinds of problems if you didn't get rid of him because of all the... So it's good to put in the back of your mind. There's so many rules in math, aren't there? But it's good if you put in the back of your mind, pluses and minuses are almost always the problem. They really are. So when I say get the root alone, really I mean get rid of the pluses or minuses. It's okay to leave something times. Okay, so what does that mean then? What would be my next step? I'll go on to step 2 and I'll do parenthesis 2 power, parenthesis 2 power. Again, I'm doing this because I don't want to make fractions. Okay. Now, what will happen over here? What's that? Yeah, good job. That 7's going to be squared because he's not under a root. He's not protected. 7's going to be squared. But what about the root x minus 1? That'll just stay x minus 1. It'll just cancel out the root, but it won't square the x or the 1 because they were protected by the root. Does everybody see that? It's like having an umbrella in the rain. You don't get wet. That stuff under the root does not get squared because it's protected by the root from the square effect. But the 7, he's got no umbrella. He gets wet, right? He gets squared on. All right, rained on. Sorry, that's a weird phrase. All right.
That works though.
Yeah, all right. That helps. No weird phrase is too much for me. All right, so x minus 1 squared, I go ahead and write 2 of them. Why didn't I write 2x minus 1s over here?
Because it was only 1.
Because it was protected. Again, that root shields it from the squaring, right? All right. All right. I'm saying all that because these are the questions I've heard over the years. All right, so like that, and then the other side, just FOIL it out, x squared minus x, boom to boom, minus x plus 1, like that. So we got the roots all out of there, so that's good. So then we got 49x minus 49. This is x squared minus x is minus 2x. To there. Okay, now what should we do?
Get a 0.
Get a 0, yeah. We shift gears, right, into a whole nother problem type. There's no more roots, but now there's x squared, the sea monster, I always call it. Get a 0, right? As soon as you see that x squared, it's a whole different game plan now. Get a 0. Where do I get the 0? On the opposite side from x squared, right? We always want 0 to be the opposite side. So over here on the left side, because x squared's on the right side, so I want to make the left side become 0. So what do I do? Opposite of everybody over there. So minus 49x plus 49. And whatever you do to one side, do the same thing to the other. And that'll put a 0 here. Is that good? And the other side will be x squared minus 51x plus 50. Is that good to there? Probably going to go to a new screen. I'll come back. So it's 0 equals x squared minus 51x plus 50. It was we good? 1 and 49, 50. It's all positive. That good so far? And so now we need to factor. right? Because we're on the x squared plan, which is get a 0 and then factor, huh, with the 2 parentheses. So we have to do the 2 parenthesis factor thing. So what two numbers multiply to be 50 and add to be minus 51? What times what's 50 and can make 51 when you add them? 1 and 50, huh? Both, or, oh, that's not going to work, is it?
Yeah.
Is that? It is supposed to be plus. Yeah, I'm messing up. It's got to be plus. So the two negatives multiply to be positive 50, and they add to be negative 51. Now it's working, huh? Good. I had the wrong sign when I changed screens. Okay, so then you know the two answers, just opposite, huh? Plus 1, plus 50.
50 is a good answer.
Is that the good one? So now we have to check them, right? This method always has to be checked. That's why these get kind of long. So you do have to check them. Let's do that.
Could we do the quadratic equation and get a good answer?
Yeah, we give you the same two answers, the 1 and the 50. No, it's the same as factoring. It does the same results factoring well. 1 and 50. So now where do you check? Go back to the original. Whenever you check with the very original question. So 7 root of x minus 1 plus 1. So 7 root of x minus 1 plus 1 equals x. Is that right? Yeah. And put in the 1. Put in the 1. Put in the 1. So 7 root of 1 minus 1 plus 1 is 1. 7 root of 0 plus 1. That's what's square root of 0 is just 0, huh? 7 times 0 is 0. 0 plus 1, does that equal 1? Yeah.
Oh, okay, so 1's good.
So the one works fine. The 1 makes the left side and the right side the same, doesn't it? How about the 50? Does that work also? I think so.
Yeah,
What you got? Let's see.
I think.
So square root of x minus 1 plus 1 is x. So put in the 50. Put in the 50.
The square root of 50 minus 1 is 49. Square root of 49 is
That would
7.
be 49. And the square root of 49 is 7. Those are times, huh? Because that 7 is right up against that root, no symbol in the middle, so that's times.
So 7 times 7 is 49 plus 1 is 50.
49 plus 1 is 50. 50 equals 50. So this time they're both good answers, aren't they? So they're both keepers. They're both good. So they want you to put both answers with a comma. Either order, 1 comma 50 or 50 comma 1. Both are good. So sometimes both are bad. That'd be no solution. Sometimes both are good. Sometimes one good, one bad. Questions on that? That okay? Those are kind of long, aren't they, with the checking and everything? All right. You all got that down? I'll keep moving. Yeah, so here we go. So 3 plus square root of z minus 7. So square root of z plus 8. Okay. So this is going to be a considerably harder problem.
Not like this.
And the last one wasn't easy. So this is where this section of the course, these last two exams are hard. I'm glad so many of you did so well on the third exam and the second exam. So it's good. Things get a little messier in the sections of the course. So double rooters, 2 roots. These are hard. So what are we going to do? Well, what's the game plan for roots? It said get it alone, right? Remember the root with equals plan. Get the root alone. So is the root alone? Well, there's 2 roots. This one's alone, but this one's not alone. He's got a plus 3 with him. What's the best we can do? I mean, we've got 2 sides, left side, right side. We've got 3 items. Not everybody's going to be alone. So this is as good as it gets, but that will be a problem. Because of that, it's going to make a big mess out of this problem. But this is the best we can do. It's all we got. So let's just go ahead and parenthesis 2 power, parenthesis 2 power. You should be thinking in your mind, this side right here is going to be a big pain because of that plus sign, right? Pluses and minuses cause all the problems in algebra. It's that plus sign there. It's going to make a big mess out of that. So on the left side, now, you have to actually write 2 of those. So let me write it out. So 3 plus the square root of z minus 7. Whoops.
Distribute?
3 plus, yep, we got a FOIL. The other side is much easier. The rooting and squaring just cancel. See how that's why we like to get it alone. See how simple that side is? Because the root was alone, the squaring just cancels the rooting.
So it doesn't cancel that root because it has the 3 attached to it?
Right, exactly. Yeah, yes, well said, Kara. That's exactly, yeah, because you might think, well, can't that just happen to the other side? Can't you just make that 9 and just remove the root like that? No, it's not true. You could prove it with numbers. You know what I mean? I think it's important to see why other easier ways are not allowed. You know, you might think, well, can't I just square that 3, that'd be 9, and just remove that root? No, let me just show you with numbers. Think about whatever you want, like 3 plus 4. If you have a square on 2 things added, can you just square the first number and square the second number? Is that true? How do you know this is not true? The 3 plus 4 squared is not 3 squared plus 4. So you can't just square him. How do you know?
You have to do what's in the.
Yeah, well, what is this? No, don't give me any fancy math rules. Just look at the numbers. What is this? What's 3 squared? What's 4 squared? So what is this? 25. Is that what this is? What is that? Yeah, that's 7 squared. What's 7 squared? 49, not 25. Not true. Right? I don't need some fancy math teacher or some fancy math rule. I was looking at the numbers. Right? Simply not true. You cannot take a 2 power that's got 2 things added in parentheses and just put it on each one. It just changes the truth, doesn't it? It's just not so. So that's why I can't just take that 2 and go boom on him and boom on him and boom on him. It's just not true. It's not the truth. So I can't do that. What do you do instead? You got to write a whole parenthesis, and do the whole FOIL thing, don't we? And why? It's like Kara was saying, it's that plus. It wrecks everything. I'm telling you, it is. It's those pluses and minuses gluing things together, the Costco and all that. So you have to do it the long way. You have to actually write 2 parentheses, FOIL it all out, and it'll be a bit of a mess. But it's what's true, and we have to do what's true. So, all right, here we go. So, yeah, we'll just start cranking it out. So 3 times 3 is 9. Plus, now what happens when the 3 hits the root? Stays outside, because outsiders, insiders, yeah. So 3, I need a little more room, I think, here. Let me just bring it down here. 3 root of z minus 7. He's done. Now the other guy's going to go to both. So the root z minus 7 hits the 3. Same thing again, huh? The 3. These are all added. These are all separate added terms, aren't they? The 3 stays outside. And then root z minus 7, root z minus 7?
Z minus 7.
Regular z minus 7. Right? Because, like root 11 is plane 11. 2 of the same thing in a root is one plane. Everybody see what happened there? This and this together made a plane z minus 7. And the other side, that's simple. Just z plus 8. See how much worse it is when you don't have the root alone, you got something added to it, you can do all that mess. Okay, let's keep going. These 2 are like terms, right? We can add those 2. So we can go 9, 3 root z minus 7, and 3 root z minus 7 is 6 root z minus 7. Yeah, just add the terms in front. Plus z minus 7 is z plus 8. Good so far. And we can actually do another pair of like terms. Do you see it? I can just take the 9 and the minus 7. Doesn't matter that they're far apart. They're just plain numbers. Just put them next to each other and subtract. 9 minus 7 is 2, right? Good to there. The 9 and the minus 7 made 2.
But now you can take the c plus 2 and subtract it from the c plus 2.
So now let's think about what our game plan should be at this point. What should our game plan be at this point? It looks like we've still got a mess. It's hard to see this as progress, but it is actually. You know what? You know where our eyes should go, because a lot of math, especially this exam and the next, are harder. Average. I don't want to scare you, but I want you to know what you're up against. Average grades drop at least a grade. That's what the average does. Doesn't mean it has to happen to you, but I'm telling you, semester by semester, No, I think what people need is appropriate fear. There's just like if you're going into a competition against a team, the team's better. You want to know. You don't want to just like be surprised, right? So I want you to know grades drop grade and a half to 2 grades usually. This material is quite a bit more difficult that's on these last 2 exams. So with that said, Ajane, what do you want to say?
Do you drop the lowest?
The final will replace your lowest grade. That's true. That's true. So if you're in really good shape in the first 3, you're in pretty good shape. There's 2 hard ones coming, but yeah. All right. So with that said, you really got to spend some time on this, and you got to really give some effort. It takes more effort than the first 3 took. The material is just messier. So what should we do? Well, you want to have that recipe, identification, game plan. There's something you should be looking at here, seeing and letting that direct you as to what the game plan is. And what it is it's this piece. Whenever you see a root, anywhere, anytime, you go into the root recipe game plan, which is still on the board, on the screen. Get that root alone, and then the 2 power both sides and the check thing, right? So let that direct you at this point. Look at that and go, I don't know about all this big mess, but I know I got a root, and I know what I'm supposed to do when I got a root. I need to get that thing alone. That's exactly our plan. So that's how you keep from freezing up and don't know what to do next. You see that root and you go, whenever there's a root, I know the plan. Get that root alone, 2 power both sides. So let's move towards getting that root alone. So what should I do to get that root alone?
Subtract 2.
Subtract the 2 and subtract the z for both sides, huh? And whatever you do to one side, got to do the other. Subtract the z, subtract the 2. So let's bring it up here. What does that give me? 6 square root of z minus 7 equals, and these just cancel. What's that, 6? Yeah, just 6. And last step to get that. Now, normally I leave numbers multiplied here, but I could divide that 6. It'd be nice. It'd just be 1. So let's do it. So I do it if it's easy. I don't if it's don't. Numbers multiplied, it's your option. You could leave it, but if it's easier to divide it, do it. I'm going to divide it. That's just going to be root z minus 7 is 1. What's that?
You don't do step 2 right now?
Oh, I'm still doing step 1, still getting the root alone. Now the root's finally alone. Now I will do step 2, I'll second power. Yeah, Kara, if you second powered at this step, that's okay too.
Oh.
That's okay too, that'll work too. If there was an ugly number over here that 6 didn't go into, like 7, I would have just second powered right there. But if I can divide it, it's nice, I think, oh, that'll be easier. So I just do that. Yeah, so I just kind of do whichever's easier. So yeah, now I will do step 2, and I'll 2 power both sides. Kind of running out of room there, I'm going to move it if that's okay. Man, I forgot what it is. So this is number 9. And we have root of z minus 7 equals 1. So everybody good to there? So I saw the root, and whenever you see a root, the game plan is get that piece alone. So I got that piece alone, and now 2 power both sides, huh? 2 power, 2 power. And here the rooting will just cancel the squaring, because there's nothing outside that root with a plus or minus or anything like that. So it's just z minus 7. 1 squared is just 1. And then add 7. And we got our answer, 8. And we're not done. Why not?
Because we have to check it.
Check it. After all that, we still have to check it. It might be a no solution. So now we have to check it. Where do we check? First step. Yeah. So go back to the first question before I did anything to it. 3 plus root of z minus 7. So 3 plus root of z minus 7 equals root of z plus 8. Like that. And then put in that 8. Boom. 3 plus the root of 8 minus 7. Root of 8 plus 8. Good so far. Just checking it. 3 plus the root of 1. This is the root of 16. Square root of 1 is 1.
Yeah. 4 equals 4.
4 equals 4. So it works. So the answer is indeed 8. There we go. Questions on that one? Well, you can see where this material is tougher, huh? It's just messier. We're just getting it. We're kind of edging into advanced algebra now. This is intermediate, but This is the end of intermediate. It's getting kind of advanced, the algebra is now. So like that, you guys are in advanced algebra kind of.
I don't feel like.
Question? Didn't you always want to do that? Get into advanced algebra? Wasn't that a goal? No? It's not my desire. I used to always see my teachers the way they could just whip algebra around and never make a mistake. I just think, wow, that'd be cool to be able to do that. But you don't feel that way, huh?
No, actually.
I mean, I was just weird that way. All right. There we go. So number 10. Double rooter. So do you recognize them? So you know it's going to be one of those long ones. 2 roots, huh? 2 roots.
2 roots on the same side. Well, this one looks easier than the last one.
So let me encourage you. Look at the recipe I gave you, the steps, right? And follow those steps. If you take the wrong first step here, it's all over. And it's no mystery. I wrote it for you. Right? I wrote what to do. Look at step number 1 in particular. Make sure you follow step number 1.
Well, that one would be
So what's the first step say?
Get the root by itself.
Get the root alone. So don't skip that step. Don't do 2 power right now. Right? On that, I'll show you. Yeah. So notice they're not alone, right? So here's the wall. They're together on the same side. They don't like that. They're loners. They want to be alone, right? So we can't 2 power both sides right now. We have to move one of them over. So I'll just grab this one and move it over. It doesn't. Yeah, I mean that's probably the easiest thing to do. Just do that. So I just want to make sure you don't get tripped up there on that first step. So I gave you a minute to try that. If it bugs you to put the root in the back, it's totally fine to have the root in the back. You can put it in the front or the back. It's totally good either way. Does that make sense? Now, this one's alone. The other one's not, but at least one of them is alone now. That's the best we can do. Now, 2 power both sides. Everybody see how that's following the recipe, right? Get one of them alone, then 2 power both sides. So don't forget that get one alone thing.
It's
2 power.
+6 because it was originally a negative.
So this negative here
Is attached.
became that positive there.
Okay.
Yeah, the roots inside the like the things in here don't change. We're not going in. We're not going in there. That's a different world. Yeah, I'm just talking about the out front negative became an out front positive.
Okay.
Yeah, yeah. Good question. That is a good question. Everybody see that? So that out front negative here became an out front positive when it moved to the other side. Huh? That's all that changes when you move things to the other side is any out front signs, right? All right, so take it from there. Now it's just like the last one, which is hard, but try that. So have you noticed there's an easy side and a hard side? What I mean is the left side's going to be easy because the root's alone. So just boom, nothing to it. Just rooting, cancel, squaring, 4y plus 12, piece of cake. But the other side, way harder because of the plus sign and the glue and all that. Right? Everybody good with that? See how there's an easy side and a hard side? Pretty much how these always work. Like that. Is that good? Take it from there. Foil out that right side. So 36 plus 6 root y minus 6 plus 6 root y minus 6 plus plain y minus 6. Is that okay? Everybody okay with that right side, how I foiled that out? Questions I can answer on that? That's probably the messiest step right there. Okay. Everybody see why I got a plain y minus 6 back here? Because root times root made a plain y minus 6. Okay, now gather like terms. And get that root alone. Huh? Whenever we have a root, the plan is to get it alone. So I'm going to go 36 minus 6 is 30, plus 12 root y minus 6 plus y. 36 minus 6. Everybody good there? See what happened? How what I gathered together is like terms and stuff?
You subtract the y too, right?
Yeah, exactly. Yeah, so now the game plan is to get this root piece right here alone, huh? Whenever we got a root, the plan is get that thing alone. So subtract the 30, subtract the y from both sides.
Can we still divide by 12?
I don't think so. I'd leave the 12. This time I would leave the 12 probably
Okay.
because it won't be clean.
So just square it after that?
Yeah,
Okay.
right. This making sense? Questions? So now subtract the 30, subtract the y from both sides. Here's the equal sign.
Ugh.
Gone. And then we got 3y minus 18 is 12 root of y minus 6. Good to there? Now, I would not divide by the 12 here because it's just not going to be nice. So I'll leave it. Remember, you can leave a number multiplied by the root. It's your option. If it, I don't want to divide by the 12. I'd have some weird fraction. So instead, I'll just leave it. And now I will parenthesis 2 power both sides. And the mess will continue.
Yes, it will.
Right? Because that's what you always do with the root, right? Get it alone in 2 power. Get it alone in 2 power both sides. So this is number 10, so 3 minus 18. So it is 12 with 1 minus 6. So we good to there so far? Then square both sides.
It's gonna be y squared, but
Yep. So 3y minus 18. 3y minus 18. Oh, 18. Now when you square the other side, the 12 is going to actually get squared and become 144, and then the root will be canceled. Right, everybody see that? And then distribute. 9y squared minus 30. 54y. Minus 54y. 18 times 18, somebody got that?
324.
324, thank you. And the 144 distributes.
864.
Thank you. Look at this. Isn't this fun?
No. No.
This is a mess, huh?
Subtract 144y from both sides and add 864.
Let's gather some like terms. Minus 54 is minus 108y. We good to there? What in the world should we even do now?
Combine like terms, give us
Questions to there? You guys okay to there? This making sense? What should we even be doing now? Get a zero. Exactly. Right? Because y squared, the sea monster's here, right? When y squared's there, you know the game plan. Get a zero on the opposite side from y squared, right? We good? So we get a zero over here. So that means do the opposite of that guy and the opposite of that guy. So that'll make 0, because these will both cancel. Whatever you do to one side, no choice. Same thing to the other. This problem just gets worse and worse. 9y squared minus something big.
252.
252
Plus
y.
1188, I think.
1188. Yep, it is. Look at that.
Equals 0. You can take out the 9 though.
We good to here? Now we got to factor. Yeah, you should factor out the 9. When you see that 9 in front, you should try with your calculator dividing the other two numbers by 9. And you'll see that 9 goes in. So that'll make it way better. And tell me how many times.
Oh, minus 28y plus 132.
Thank you. You see that? I factored out that 9. 9 goes into all of them. You guys enjoying this problem?
No.
It is. It just keeps going and going. Now we got to finish factoring that. How do we finish factoring that 132? What do we do?
What adds negative 28?
Remember, use your calculator. We've done these before, right? You say what multiplies to be 132, adds to be 20. You take your calculator, take 132, start dividing by things. Divide by 2, 3, 4, 5. Actually, I won't even think about it till 6. What is 6?
22.
6 and, oh, beautiful. There it is. 6 and 22. That can make 28. Right? See that?
Thank you.
There it is. Remember how you do those big old numbers like that?
So it equals 22 or 6, but now we have to go all the way back and check.
So let's factor. It's 6 and 22. Both negative, because two negatives multiply to be positive, and they add to be negative 28, don't they? So what about that 9 in the front? What do we do with that thing? Nothing. Totally ignore it. It doesn't have a letter. We only care about the parts that have letters, because only letters, variables, things that can change, vary, can multiply to be 0. The 9 can't make anything 0. Right? You with me logically? What if I said, hey guys, 9 times something's coming out 0. What does that mean logically? One of those somethings can be 0, but doesn't mean anything about the 9. Logically, does it? See how the 9 has nothing to do with the logic? So whole numbers in the front, whatever, who cares? It's just the two parts that have letters that can vary, can be different things. Either one of those can be 0. So it's just 6 and 22, right? The answers are just 6 and 22. Forget about the 9. So the answers are 6 and 22, maybe. Now, after all that, we have to check. It's a never-ending problem. So let's go there and check.
Well, math itself gives you 3 chances to get it right.
That's right.
I would
Try
just put in
both,
one.
try one, try the other.
Right. Narrow it down.
So y equals 6, y equals 22. I'm going to check. And what was the original question? Square root of 4y plus 12. I'm going to change that. Square root of 4y plus 12. Minus square root of y minus 6 equals 6. So there was the question. Put in the 6. Put in the 6. Square root of 4 times. I'm going to go quick here if that's okay. I'm tired of this problem. Minus the square root of 0. That's the square root of 30. 6 minus nothing. That's 6 minus nothing is 6. Yes. How about the other side? So square root of 4y plus 12 minus square root of y minus 6 is 6. Put in the 22. Put in the 20. That's going to be 88 plus 12. It's going to be 100. That's going to be minus 4, 16. Is a 6. 10 minus 4 is 6. Yes. They're both good. Both answers are good. 6 and 22 both make the thing true. So both are good. 6 and 22. There we go.
That problem took a whole page.
Yeah, sure. Took me 3 screens. So that won't come to the casual, will it?
No.
This is the bar the state of Casualnia has laid down, because they want a person getting a bachelor's degree to have a certain amount of discipline, hard work ethic, and this is what they do to weed out those they want from those they don't. I mean, that's the reality. You know, what's this for? This is for weeding out people that don't have the discipline and hard work to get a bachelor's degree. I mean, that's the truth, right? Isn't that the truth? Yeah, unless you're going to be an engineer or something, you'll never do this. So why does the state, it's not me, don't look at me, it's not me, but why does the state of California, why does the United States say everybody will finish intermediate algebra and they have these awful problems in there? They're weeding out. That's exactly what they're doing. They're putting a bar and they're saying, we don't want everybody to have a bachelor's degree. We don't want people who will not work hard enough to learn this to get a bachelor's degree, because we want a bachelor's degree to mean something. To mean something about hard work, discipline, all that kind of stuff. That's what's happening. So I want to be straight with y'all. I have to report an honest grade. I want you to all succeed, but you need to work. You need to work at this. This will not come to the casual. It's not meant to. It's meant to weed out the casual and say, sorry, casual, no bachelor's degree for you. That's what it's meant to do.
So
Don't let that happen to you.
These last 2 units are filter units.
I guess so. Yeah, I mean, that's just what I've seen over the years. I didn't make it up. I'm just here to help you with it.
My chem.
Kara,
So we get more than one card, right?
give more than one. On the final. I'll give you a whole sheet on the final.
So what about the next day?
Every now and then, just moving X's around. This is nice. So, do you ever wonder, like, when you go up high building or a high mountain or something like that, how far can you see? I mean, not just your eyeballs, but like as far as, the curvature of the earth, right? There's a horizon, there's a limit to how far you can see. The higher you go, the further you can see towards the horizon, right? Well, how do you know? Well, there's an equation. It's right there. There is the equation between how high up you go and how high you can actually see. How far away, not how high. How far away you can actually see. How high you go from how far away you can see. So h is your height. Where's it say that? Yeah. Height is h in meters. V is kilometers to the horizon. How far you can view. V for view. H is how high you are. V is how far you can view in kilometers. So these will be way easier. They're saying you can see about how many kilometers out on an airplane window at a height or altitude of 13,000 meters. So the question is, plug the 13,000 in. Yeah, what does it plug in for?
The H.
Plugs in for the H because it's the altitude or the height. Huh? No, H is meters.
No, but they want the answer in kilometers, don't they?
They do. They want the answer in kilometers, and V is kilometers. But this number here, I'm plugging in for H, and H is, notice, in meters.
Well, a
Okay.
kilometer.
So they don't have to be the same as each other.
Sorry, you're gonna have to do a calculation at the end
A
anyway.
kilometer is 1,000 meters.
No,
That's what I'm saying.
no. I like, for example,
You can see about blank kilometers.
Right, right. Right, so what this formula is saying, I hear your question, I understand how it seems confusing at first. Bear me out, listen to me for just a second. Somebody can make up a formula, which they have, in which the units are automatically changed because they made it that way. So for example, I could say, you know that 3 feet is 1 yard, right? I could say, hey, take how many yards, call it y or whatever, and multiply it by 10, and that will be the number of feet. What will that be? I'm trying to think of it right now. That will be, I'm not doing a very good example of this. So I'm not helping. I don't think I'm helping.
But I get what you're saying.
Yeah, so it's already taken care of, is what I'm saying. So already this formula says if you plug h here in meters, it will automatically come out v in kilometers. That's what it'll do. So we don't have to worry about any of that. So just plug in the h is 13,000, and simply hit the buttons on your calculator. That's all that is. Take 3.5, take square root of 13,000, and what do we get?
That one number.
I mean, I could do it in my head, but I hate to show off, so. What do you got, Kara?
I don't know if it's right. 399.0613 forever long.
Does anybody else got that? Looks reasonable, yeah. And they said round to the nearest whole number, so we'll just say 399. You can see about 399 kilometers, about, almost 400 kilometers. Kilometers are a little smaller than miles, huh? So that might be, I don't know, 250 miles, something like that. So you can see 250 miles. If it's clear up there, you're in the plane, 13,000 meters high. Kind of a neat little relationship, huh? Good? Good with that? Much easier than those last ones. So it'll be a little more tricky. We'll have to do a little more work. It's not just hit the buttons. So same formula. V equals 3.5 square root of h. And same kind of thing. And they say a steeplejack, what is a steeplejack? Whatever it is, can see 42 kilometers to the horizon. So that's how far they can see. So that's V. Yeah, everybody's seeing that's the V. And then they're going to go blah, 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 solve for h. Meters high, right? They want me to solve for h. So I only need to read all the rest of the words, plug in 42 for v, solve for h. So how should I solve that for h? What's the game plan? What's the recipe for a square root? Square root with an equal. Step one is get the root alone. Now, normally I might think 3.5 is difficult, but I'm just going to hit the buttons anyway. So let's just do it. So divide by 3.5 on both sides. Somebody got that? What's 42 over 3.5?
That one number.
10, 11, 12, something like that. 12 straight? Oh, okay. Oh, yeah, it is. Okay. All right, and then what do I do now? 2 power, right? 2 power, 2 power. So h is 144. 144 what? It's h, so that's meters high. So that steeplejack must be 144 meters high, whatever a steeplejack is. Nobody Googled it? Tell me what a steeplejack is. Somebody told me before, and I just forgot this. I don't know what the use of it is. I'll forget again. All right, good? Well, good with that? I'll move on. Okay, r equals 2 square root 5L. And R is your rate, your miles per hour. L is the length of your skid. So police can use this to figure out how fast you were going if you skid by measuring the skid marks. So how far will a car skid at 70 miles an hour? If you're driving 70 miles an hour, hit the brakes, skid. How far will you skid? So so the 70 is the only number they're giving me. 70 will go in for rate. Yeah, because it's miles per hour. 70 is miles per hour. Good. So can you solve that for L then, the length of the skid? Solve that little equation for L. So use the square root recipe. What's step number 1? Get that root alone. Like that. That good? And then 2 power both sides. I get the root alone, 2 power both sides. 35 times 35, somebody got that? 1225, thank you. And over here, the rooting just cancels the squaring, it's just 5L. Good to there. And then divide by the 5. And I don't know what that is. 24. 245. Okay, thanks. 245 feet, long skid. It's a long skid. Questions on that? We good with doing those? Those word problems are better than the other ones, right?